All right, we are going to go ahead and get started. So again, thank you so much for joining us today for our webinar, API Security, the New Attack Surface. We have got an incredible panel lined up, everybody, today. And by the way, my name is Bob Cruz, CEO of Checkpoint Technologies. I'm going to be acting as the moderator today. And as I mentioned, very excited to have this group of experts with us. We have got Stan Wiseman with Micro Focus. He is the North American Chief Security Strategist, and he'll be presenting. And we've got Clyde Ford with Checkpoint Technologies, VP of Technical Services. And we also have Rick Smith, Micro Focus Fortify Product Manager for Web Inspect and App Defender. So I know that Rick has just a wealth of information. So Stan, Clyde, and Rick, thank you so much for being on today. We're very excited to have this information you're going to share with us. So everybody joining us, I just want to share with you, you should be able to see the GoToWebinar instructions, the control panel. We absolutely would love for this to be as interactive as possible. And you know, one of the things I really want to emphasize is we all hope that your families and loved ones are safe and well during these crazy times. Just to hang in there. We're all in this together. And please feel free to reach out to Checkpoint Technologies if there's any way that we can help. But just hang in there. So this is your GoToWebinar control panel. This is where you can submit questions. We absolutely welcome questions. One of the things I want to share with you all, this webinar is being recorded, so it will be available. We'll be more than happy to share that link with you. And then in regard to the slides, we're also more than happy to share those in PDF format if you just send us an email or a message requesting those. The other thing I want to emphasize, many of you may have noticed in the invite that we are providing an Uber Eats coupon code for those of you attending and completing the survey. It's a very brief survey at the end of the webinar, because Micro Focus and Checkpoint Technologies, we are always looking to improve our webinars. So take just 2 or 3 minutes to fill that out, and we will be more than happy to get you that Uber Eats coupon code, and we'll get that out to you today. And one other thing on this question panel, you know, if Clyde, Stan, or Rick should happen to break into a good joke, we need that affirmation that we're funny. So you can just type in LOL or haha. Believe me, it makes us so happy when we see that. But again, we're going to just dive right into the presentation. So with that, I am very excited to turn it over to Stan. So Stan, please take it away, sir.
Hey, thank you, Bob. Rick and I really appreciate you giving us the opportunity to participate in the webinar and to discuss this important issue. And I just want to reiterate what you said about everybody keeping safe. It's kind of crazy times, but at least we can still stay connected with Zoom and GoToWebinar and all these lovely conferencing and technologies. So go ahead and go to the next slide. Thank you. So before we get into the risks associated with APIs, I know we have a broad range of participants on the call today. And so I want to spend a little time defining what they are and explaining why they're important. So applications or application components can leverage APIs to connect to other applications and communicate autonomously. You know, APIs are found in all types of different applications: customer-facing, partner-facing, internal applications, in support of mobile, SaaS, and web applications. And like basic web requests, go ahead and go back if you would. There you go. Thank you. Basic web requests, API calls incorporate URIs, method headers, and other parameters. And Rick is going to show some of those in the demo. And APIs aren't new, right? I mean, they've been around for a long time. Back in the early 90s, I was with Oracle, and I helped with the porting of the relational database over to different operating systems, leveraging APIs. We had an operating system dependent layer that leveraged the operating system APIs. But over the last few years, architectures of applications have significantly changed. If traditional web applications, the data processing is done on the server side, and resulting web page is then sent to the client browsers for rendering. And as client devices have become more varied and powerful, modern API-based applications use APIs to send and receive the data from the backend server to provide the functions to the application. Now, you remember the early days of mobile technologies when you went to your banking app or your favorite travel site on your smart device, and you would simply basically open up a web browser, essentially the same kind of accessing of a web page that you would do on your desktop computer. And that really wasn't effective with mobile devices. The performance wasn't very good. And as a result, financial, travel, retail organizations started building API-laden mobile applications that would, in real time, send through APIs, check balances, money transfers, seating availability, product availability, without the use of a browser. And this does have security implications, and ramifications, as more and more of the functionality moves from the sturdy back-end processing world into the highly agile and changing mobile world. So this transition has, helped us do a lot of innovation. And without APIs, we would not be able to have this kind of rapid innovation. So that's why it's very important. Go ahead and go to the next slide now, Bob, if you would. So, now that we recognize that they're important, what kind of risks do they pose for these modern apps? And, basically, if you think about it, APIs define a backdoor to adjacent systems or applications for those who are intent on gaining access. Now, that access could be legitimate, and we'd like to think that it usually is, but it could be otherwise. And detailed documentation is usually available, not always, but usually available for APIs to provide transparencies to developers to help them understand how to use those APIs. But that documentation can also provide a blueprint for hackers to utilize APIs in their attacks. And APIs, by their very nature, expose application logic and data, therefore providing access to multiple sources of potentially sensitive data and mission-critical services. So they can, you can view this then as broadening your application layer attack surface. All right, Bob, go ahead and go to the next slide. And so the first step is getting visibility into what APIs your applications are exposing. So that way you can have a way of mitigating the potential abuse. All right, next slide. We have a very strong research group within the Fortify team. They're the ones that actually do all the language analysis to determine what potential vulnerabilities exist in each language, and they do an annual report. And we'll provide a link to that report at the end. But in that analysis, they look at a lot of the scan results we get from our Fortify on Demand. And in 2019, they looked at the results of 11,000 different web application scans, and it showed that API abuse issues have basically doubled over the last several years. And specifically, as you see here on the slide, 35% of the web applications they analyzed had API abuse issues, and 52% of the mobile applications had abuse issues. And so understanding API vulnerabilities and weaknesses can help you gain a more comprehensive view of potential attack vectors that can be used to breach an application. All right, Bob, go ahead and go to the next slide. So how do we understand these risks, and what steps can we do to mitigate it? Thanks. Most typical web attacks, such as injection, credential brute force, parameter tampering, they also work well against APIs. But one of the things that was noted, there's enough differences between the standard web application vulnerabilities and weaknesses that there was a project launched at OWASP. If you're not familiar with OWASP, it's the Open Web Application Security Project. It's been around since the early 2000s. Great source of information. And they launched a project to create a top 10 list for API security. And that's what these are here. These are the top 10. And the list sort of rounds up the most critical API risks, and they'll update this periodically. This is the 2019 top 10 list. And it's not necessarily all encompassing, just like the standard OWASP top 10 isn't necessarily all encompassing of all the things you need to be worried about. But it does help you as either a cybersecurity professional or as a developer understand some of those potential risks. And it does a good job of giving you insight as to not only what that particular vulnerability is, but also, how to potentially mitigate that. So if you look at like API 3, excessive data exposure, and they're addressing the issue of the fact that many times developers expose all the object parameter properties without considering the sensitivity, and they sort of are assuming that the client is going to perform the filtering before displaying anything to the user. And that is sometimes not what you want. You won't necessarily have that sensitive data exposed. Or API 4, lack of resources and rate limiting. Again, that's a potential that the API itself does not impose restrictions or on the size or number of resources it can be requested, and you're leaving yourself open for a DDoS attack or a DOS attack. So you need to be cognizant of that. So what can you do to address these issues? And I think, again, as far as a place to start, it's vital to get better visibility into what APIs exist, who owns them, which endpoints are exposed, etc. Unlike web applications that you can crawl, APIs have nothing to crawl, and it can be difficult to discover. So using API collaboration software like Swagger Hub or Postman, which can provide a full picture of an API and all its interactions, is a great place to start. The other way these collaboration tools can be used is they can be used as input into vulnerability scanners like Fortify Web Inspect for vulnerability analysis. And that gives Web Inspect a greater understanding of the APIs of the app. And then scanning the APIs with Web Inspect can help identify those weaknesses and vulnerabilities, giving you the visibility you need to take remediation actions on those weaknesses. Another consideration is how to cope with authenticated APIs. You want to have authentication and authorization of objects and users, but it can get quite complex in modern applications, and scanning that and coping with how you can deal with ANA can be complicated. But Web Inspect can cope with these complicated authentication and custom parameter requirements. And it can provide greater coverage for your APIs and your scans, as well as help you identify any potential weaknesses in the authentication and authorization functions and features to identify potential compromise areas. Finally, another additional control organizations are starting to layer in are API gateways like the NetIQ Secure API Manager. And these API gateways provide a layer of governance that help create, manage, and secure and measure the API's use. So it's another layer of control that you're seeing folks starting to apply. So that hopefully gives you a good overview. I'm going to now hand it over to Clyde, and Clyde's going to share his perspective on API security testing. Clyde, over to you.
Okay, appreciate that, Stan. So again, Clyde Ford with Checkpoint Technologies. What we'll review today, very briefly, we'll look at some of the best practices and recommendations around testing of our APIs. So Bob, if you want to forward, please. There you go. So typically developers are really good at coding, but not so much with documentation. And in many cases do a less than satisfactory job collaborating with the business to fully capture and communicate their understanding of both business requirements as well as the IT requirements back with the business to ensure everyone's on the same page. When the test team is building out their API security test cases, they need to get out of the mindset of doing testing as usual, which is primarily focused on functionality or security, those types of things. When doing API security testing, the test team activities need to expand and include or address API abuse, where the tester would try to identify vulnerabilities in your API business logic. An example test may include a more technical test resource, which is critical, posing as an agent or an attack agent who makes repeated and large-scale API calls on an application server that results in denial of service, as an example. API misuse, which is really more on the development side. The issue here is that developers frequently reuse functionalities of third-party projects or libraries and are not always familiar with the correct usage of an API, which could lead to bugs or unexpected behavior of your software. So again, that would be more of a development test. Equivalence classes, which is an important software testing technique used by the team of testers for grouping and partitioning test input data used to do your API testing. Boundary value analysis is another type of test where test cases are generated using the extremes of the input domain, such as minimums and maximums and variant testing. And then finally, there's error handling. Testers need to validate how the system responds during improper data entry and also to check to see if error messages generated are meaningful to the end user or if they even get an error message at all. So in the end, who should own API testing? It's really a combination of two teams. Developers, as we talked about earlier, perform both unit testing, which is more technical testing of the API, as well as functional unit testing, where the development team is working with their business counterparts to validate the requirements as part of their API testing. However, I would contend that the test organization is the primary responsible team for owning your API testing and to ensure a more vigorous level of both technical and functional testing is performed. And finally, I'd suggest your organization have a strong technical resource as part of your testing. As you can see from the things I talked about above, API security testing is a lot more in depth than just simply performing functionality testing. Whether my roles and responsibilities and authorizations or performance is what it's supposed to be, and whether or not my business requirements have been satisfied, it's definitely a much more technical type of testing. So I don't want to spend a whole lot of time here. I know we've lost a little bit of time. So with that, I'll hand things back over to Rick Smith from Micro Focus.
And hey, everybody, just want to let you know we are fine on time, so no worries there.
Perfect. Thank you, Bob. So I'll hand it back over to Rick Smith, who's going to do a live walkthrough of the Micro Focus Fortify Web Inspect solution. And with that, Rick, go ahead and take it away.
So you guys can see my Simplify with Fortify slide now?
Yeah.
Okay, good deal. So very briefly, so Fortify sort of provides a platform that helps AppSec professionals and developers to identify and remediate vulnerabilities in their applications. So we mentioned Web Inspect earlier, so that's kind of our core DAS product. We also have a static analysis product, SCA. So today I'll focus kind of on the dynamic analysis side of things. There's some kind of nuances to API testing in both the static analysis sort of realm as well as dynamic, but we'll focus on dynamic for today. So to level set, running kind of a dynamic vulnerability assessment of an API has some inherent challenges, which Stan alluded to, and up until 2018, those really hadn't been tackled very well. Stan mentioned, if you think about scanning a normal web application, so something like CNN or your company's landing page or whatever typical website that you would browse to in a browser, there's something there for us to target. So that, there are pages and there are links and forums and input boxes. And what a dynamic security testing tool does is it actually crawls that. So we have an engine that actually crawls through that application in much the same way that a human would. And it enumerates the attack surface of the application, enumerates those parameters and the full scope of the app. And then it's able to attack it or audit it, looking for vulnerabilities. But an API is very, very different. There's really historically not been anything for us to target, which just means that our dynamic tools didn't have anything to scan. So that was kind of our situation in 2018. I actually come from sort of the escalation side of Fortify. So I used to handle escalations, so sort of complicated scanning issues. So this is very near and dear to my heart. So very painful process. So basically, in around 2018, an API tester would have to basically enumerate the endpoints that they want to test. So they'd have to say, here's an endpoint, here's a parameter, here's an operation. This is a delete, this is a post, this is a put, a get, those types of things. They'd have to manually inform the tool what's out there. That was a very complicated, very painful process. Oftentimes, the testing teams didn't know anything about the API, barely knew who to talk to. So then they'd have to pull in their developers. Their developers didn't really have a good feel for how their APIs worked, or didn't understand the full scope. So it was painful. Thankfully, things have evolved, and we're really, what I would say is kind of well on our way towards what I think of as kind of an invisible AppSec, which is what I'm going to demonstrate here in a moment, which is really where we use artifacts that exist as part of the SDLC that allow us to automatically scan APIs. So it eliminates all that, all that manual work of enumerating the endpoint, defining what a parameter looks like, understanding what the auth looks like. All those things that are very complicated. Particular testers don't understand what that looks like. Like I said, oftentimes developers didn't either. So kind of well on our way to that. So let me kind of show you what we use. So as I mentioned, it's the attack surface. We don't know anything about the attack surface. It's very difficult to scan an API if you don't know what the attack surface looks like. Roughly around 2018, maybe a little bit before that, Swagger came about, sort of sponsored by SmartBear. But that specification has evolved into what's called the Open API spec, which is just basically some libraries and components that allow developers to automatically document their APIs. So what ends up being generated as they're developing their APIs is a JSON payload, which gives us everything we need to know sort of about that API. This is kind of the front end of Swagger's Pet Store API. This is kind of the classic use case, or the classic scenario or sample that I use. This is a sample pet application. It's like a pet store where you can buy a golden retriever, you can sell a golden retriever, you can delete it from inventory, add it to inventory, all those types of things. The real key for us is this little file. So this little JSON file, and I'll just open it in a browser for just a moment. So it looks like this. Obviously, it doesn't look like a whole lot to you guys there. So let me switch over to Notepad++. This is the same JSON spec file. So if we dig into this, you can see I've got my endpoint information in here. As I scroll down, I've got information about the endpoints and the parameters. So this is telling us, hey, there's a pet ID parameter. The operation that we should use on that parameter is a post. The types of data that takes in. All the endpoint information, a lot of really, really good information in here that allows us to understand what the footprint of the application looks like. So prior to Swagger Hub, basically a customer would have been writing custom parameters inside a file that our tools could then consume to attack the application. Then Swagger comes along, provides this. Everyone's using this. We use Swagger for all of our components. So whether that's our management platform or our SaaS platform, our WebInspect API itself, anything that we do that has an API, we're using Open API specifications. So this has really gained a lot of adoption. We see it used basically everywhere, and it's made scanning these APIs much, much easier. There are a few gaps in what Open API can provide. So if you've got a real basic API, maybe it's sort of a monolithic API. It's all kind of self-contained, doesn't necessarily talk to remote servers, and you can really kind of consume it in sort of one file. This is a great, super easy way of testing, and I'll show kind of how that works. But if you've got a more complicated API, maybe you've got, Pet Store is actually a good example. So I'll switch over to the way we've attacked these more complicated APIs, which are things where you've got a specific workflow. So if you think about the Pet Store application, I can't really test this delete operation until I've actually created a pet in that API endpoint. Delete doesn't work unless it has something to reference. And the OpenAPI spec doesn't really give us the information we need. It just defines sort of flatly what that API looks like. It doesn't tell you anything about the workflow. It also doesn't tell you really anything about what the authentication looks like. If it's very basic, it's a bearer token, something like that. You can sort of define that in the OpenAPI spec. But authentication for APIs is generally more complicated than that. This example is just a sample API that I actually have running locally, but it's a more complicated scenario in that we do a post with credentials to this endpoint. There's a test script that this Postman allows us to basically take the token that is returned and use that in subsequent headers. So you'll see that token get passed in here as a bearer token. But the main point is slightly more complicated authentication mechanism. So for those scenarios, Postman really fits in very well. It definitely helps us to solve those problems. And so we can consume OpenAPI specification documents or Postman collections. What we're seeing our customers do, this is both on the development and on the testing side, in terms of QA testing as well as sort of security testing, is as they're developing APIs, they have to test those. They have to understand that they work. So if I'm a developer creating this Postman API, I'm able to say, hey, I've got a post, I've created this thing out there. I want to create this animal in my API. Here's my my payload. I'm telling it to create this golden retriever. I can send that and I'll get a response back saying, hey, here's the ID of that record that I've created. So I know this endpoint works. I then want to see that I can return that golden retriever. So I'll use that same identifier, send that, and I can see, okay, this API is functioning properly. Then I can send a delete. So I've sold this dog, and I can see that I get a 200. So I know that this is working. We're seeing developers use this extensively. Postman is referred to as an API IDE. So what we ended up doing was partnering with the Postman team to create an integration with Postman to be able to consume those Postman collections. And we're looking at other integrations for the future. So that's all to kind of lay the framework of how these artifacts help us. So what does that look like within our tools? So let me switch over to.
And Rick, I'm just going to throw out to the audience that, again, you're more than welcome to ask questions. And now would be the best time to ask questions in regard to the demo while Rick has control of the system here.
Yeah, absolutely. Yeah, if you got any questions, feel free to interrupt. Yeah, I'm more than happy to answer. So I'll keep going until I hear one. So you're seeing, this is actually one of our QA environments, but this is our vulnerability management platform. Sort of a holistic AppSec platform that allows you to run scans, triage the results of those scans, send them to bug trackers, do dashboarding, reporting, all those types of things. So if I look at creating a new dynamic scan, I've got this pet shop application configured. Basically, this is just a repository for the results of this application. And I can run a scan against this. I can schedule it. I can integrate it with my CI/CD pipeline, those types of things. But I have multiple scan types. So I've got the standard scan option. This is where I would just take in a URL. So I'm not running an API scan in this scenario. I'm just targeting a website basically. Also got workflow-driven scenarios for more complicated workflows. But what we're talking about today is the API scanning capability. So what I can do with this integration is I can say, hey, I want to take in an OpenAPI spec file. I want to take in the URL, and actually I forgot to copy this out, so let me grab it real quick. So I want to take in that URL. If there's some basic credentials, like a bearer token, and I already know that. I can configure that here, blah, whatever that token is. And then I can next through to run the scan. So this is kind of what I'm getting at with, I should select an API policy, but stay logged in. This is what I'm getting at with the concept of sort of the invisible API security. Because I'm referencing this JSON spec file that gets automatically deployed every time I create a new build, or if I was using a Postman collection and I've got that Postman collection shared via Postman's collaborative platform, every time this scan runs, again, whether that's via a schedule or whether it's via a CI/CD pipeline, that updated specification of the footprint of my app gets pulled in, and I'm able to run that scan. So I'll just next through this, the rest of the configuration. I'll say API demo. I can save this configuration. That saves this as a template, gives me this CI/CD identifier. So now when I'm using our Azure plugin to trigger this as part of my build, or where, if I'm doing a curl command for that matter, and I want to execute this scan using this template, this gets executed by referencing that. For here, I'll just run the scan. I'll tell it to run against any available sensor. This actually uses our web inspect engine behind the scenes. So if you're using the on-prem, the sort of more pen tester focused integration, uses that same component there. But I'll just run this, and that starts the scan. So what would have previously taken literally a day in many cases now takes a matter of minutes. Typically an API scan is a couple minutes. We're not having to crawl the application. We're not having to do any of that real heavy lifting. We're taking a fairly finite set of parameters and attacking those and looking for vulnerabilities in them. I'll do a little cooking show kind of view of this so that you don't wait for that scan to run. But these are the types of results you get. In this case, we're looking at 10 high vulnerabilities. I drill into this authentication finding. You can see, hey, this API allows us to do a delete on a particular endpoint, and we found that as a weakness. If I look over here at the info, I can get information about this RESTful endpoint's been detected, and delete is being allowed without any kind of authentication. Doesn't make a lot of sense. So that's something you should look at. So whole host of API types of vulnerabilities that we're able to uncover. Obviously OS top 10 types of things, and we're always doing research. In fact, I think we've got 12 new checks coming in our next SSR release specific to API security. So kind of give you a feel for, when I mention invisible API security, the key is being able to integrate it, set it up once, and then never have to configure that again. Just let it run automated as part of your pipelines. So with that, I guess I'll pass it back to Bob, unless there are any questions on any of this.
Well, Rick, I've got a lot of questions, I think, for the panel, which I'm hoping you, Clyde, and Stan will answer and impart some words of wisdom. But thanks for the demo. That was fantastic. So I'm going to throw out the very first question here. So for API testing, can you give me a good example of what that might look like? So what should my test teams look for related to vulnerabilities?
That's a great question, Bob. So clearly requirements are always going to be a driver for the testing that we do. So we'll start there. Organizations need to do a much better job up front and ensure security, much like data security roles and authorizations, those types of things are at the forefront and not the afterthought of the process. That says, if your team was testing Facebook as an example, we know a request is going out from my device browser, whether it's my iPhone, my laptop, my iPad, to the Facebook remote server. Based on how you've set your page up and the device you're using, a response from the Facebook server, which is your API, would interpret the request and send the data back to the target device. Is the data received from the server the response you were expecting? How do you know, right? So I would also expect error handling, variant testing to happen here as well. I have the ability to leverage a load testing tool. I might try to stress a web page and access the Facebook page using different users who have different authorizations based on their profile status with me as a Facebook page owner. Again, the testing I need to do must be defined by the requirements. And again, IT needs to do a good job of collaborating with the business to break down those business requirements into IT requirements. Testing needs to understand them, make sure that they have a full grasp of what they're trying to do. I think that hopefully that addresses the question.
And Bob, if
That's
I can
great.
add to
Anything
Clyde's response, I think that in addition to the functional requirements, that's where you also need to look at some of these non-functional security requirements. So if you look at the OWASP top 10 for API security, some of those are just basically non-functional things. You're providing too much information that may be sensitive in your response, right? Misconfigurations. And so they may not be functional requirements. So you may want to leverage those as well as far as building your test cases, or if you leverage a vulnerability scanner like WebInspect, make sure that it covers those non-functional security requirements that you need to actually include in your testing.
I think too, go ahead.
I'd add just, as you're scanning those, as you're assessing, looking for vulnerabilities on an API, just understand and remembering that, it is an API and scanning with that context. So you're not kind of overwhelming your dev teams with vulnerability categories that may make no sense whatsoever for an API. Cross-frame scripting, an API is never going to be framed. That's not a scenario that is realistic, but it's possible that a tool could detect that. So make sure that you're using a set of checks or a set of tests that are very specific to APIs, because otherwise you lose a little bit of credibility when you end up sending sort of nonsense vulnerabilities to development. So you want to make sure they can focus on the things that are real.
And I think too, the thing that piggyback off that a little bit, I think the thing that's really critical as well. So a lot of organizations from a testing perspective, right? We're functional or we do performance. I mean, we're doing our end-to-ends, we're doing systems and integration. API testing really, that type of resource, and Rick, you guys can jump in, Stan, but typically that resource should have more of a technical background. They're more developers, because I'm not really testing a GUI when I'm doing API. I'm looking at API abuse, I'm looking at misuse, I'm looking at equivalent class, and there's different things that I'm looking at that typically aren't part of the normal job description, say, of a functional tester.
Those are great points, Clyde. So thanks, everybody. And we've got some other great questions here. So I want to try to get to a few more of these. Rick and Stan, one of the things you alluded to more or less was risk and risk analysis, which I'm a huge proponent of risk analysis. This next question segues into that. What criteria do you use to define if it's critical, medium, etc.? So any thoughts on that, Rick, Stan, or Clyde?
So Rick, why don't you take that as far as how we're categorizing it within WebInspect?
Yeah, so our SSR team, our software security research team, spends, all they do is looking at vulnerabilities, identifying new vectors of attack and those types of things. So they look at it based off of a number of criteria, but it's as an example, an injection attack or any attack that can sort of exfiltrate data, is more critical than others. It's really our individual vulnerabilities get individual severity is assigned to them. For dynamic testing, that's a fairly, kind of ironically, for dynamic, it's a fairly static value, because we're analyzing the vulnerability and getting that feedback based off of a request and a response. So there's not a lot that changes in that. For static, the severity gets tuned based off of some of the assumptions that we have to make as we analyze the application. But at their core, they're all sort of set from our research group based off of the kind of the risk that vulnerability could impart. The thing to keep in mind though is that context absolutely matters. If you got a WAF in front of something, maybe that cross-site scripting vulnerability is not really a critical for you. So you have to have mechanisms in place to be able to kind of tune those down or to tune them up where they're important for you.
Great. Thanks, Rick. That was great. And now I'm just going to throw out the last question here, and then we're going to start wrapping things up. The infinite possibilities of scenarios. How do you make sure the requirements and test criteria cover your needs? Is there any AI, artificial intelligence?
Want to hit that one, Rick or Stan?
And I assume they're talking about in the tool.
Yeah, so within the tool, I mean, we sort of inherit, you know, for API testing in particular, we're going to inherit the functional tests that you're running through us, obviously in the Postman scenario that is. So we're going to be testing for security vulnerabilities in a very, very similar method and pattern that you used for your functional testing. We're actually using those types of scripts. For the open API scenario, that's where it's a little more flat. You know, it's more of a simplified approach. It's real easy. It's a real easy way to get that low-hanging fruit. But those infinite sort of scenarios, obviously, I'm not sure that you can test an infinite set of scenarios. So what we typically say is, in particular for our SaaS businesses, that's where, you know, a human comes in. What we try to do is make it real easy to tackle not necessarily only the low-hanging fruit, I mean, some of the more complex vulnerabilities as well, but there are scenarios, there are business logic types of findings that, you know, no automated tool will ever understand. So a human really comes into play there. But outside of that, you know, if it's a mobile app, as an example, you know, we can capture traffic from the mobile device, so we can actually learn how the API is being used on the back end, and then we can mimic that. So hopefully that helps a little bit.
Great, it does. That was excellent, Rick. Thank you so much. So with that, I want to remind everybody, we will answer all of the questions submitted. My apologies that we weren't able to get to all of them, but we will answer them and send out all questions and answers out to the entire audience. So once again, thank you. And I want to share this with you. Again, we will share in PDF format the slides. This one slide right here is worth the price of admission. I'll tell you, these are just some outstanding Fortify resources provided by the panel on the OWASP API Security Top 10, and then some great resources via Micro Focus. So this is definitely something that you'll want to have for reference. Just very quickly about Checkpoint Technologies, we've been a long-time partner in the ADM space with the Micro Focus solutions all the way back to 2003 in both application security as well as functional and performance. We are a business, training, and support partner with Micro Focus. So if you have any questions, please feel free to contact us. These are just a few of the services that we, Checkpoint Technologies, are very proud to provide. And then here is our contact information. And if you all have any questions specific to Stan or Rick, we will be more than happy to forward those questions along to those two gentlemen. But again, everybody, thank you so much. Clyde, Stan, and Rick, you guys just crushed it. To the audience, I apologize for some of the technical snafus. GoToWebinar was a bit slow today, so we were just out of sync because we are all remote. And speaking of that, stay safe and well, and thank you so much for joining us. Have a great day, everybody. Bye now.
Thanks, guys.
Thanks, guys.
Thanks.